Hello and welcome to today's edition of our tutorial. Today we are going to be finding the derivative of this kind of complicated function. So if f of x is sin squared x cubed all raised to the power of the ln of x to the power x, find the derivative of f of x. F of x is y, so I'm going to say y is equals to, this will give us sin squared x cubed all raised to the power. Now this x is serving as a power for this x, so according to the logarithm property, what happens here is that this x is going to drop behind the logarithm, so you have x, the ln of x. Great. X is the ln of x. I'll rewrite this as y is equals to sin x cubed all square and all raised to the power of x, the ln of x. Because the square will affect the entire sum, so that's sin squared x cubed. Now, power of power rule. If you have a base to a power and everything raised to another power, what do? You multiply the two powers. So y is equals to sin x cubed all raised to the power of 2x, the ln of x. We can take the natural logarithm on both sides. So we have ln of y is equal to the ln of this entire sin square x cubed all raised to the power of 2x, the ln of x. This entire 2x is going to drop the natural logarithm. So we have ln of y is equals to 2x, ln of x, and then the ln of, so this square is no longer here, sorry. And then the ln of sin x cubed. We can differentiate. This is where things get really awkward and difficult. We are going to use the product rule. So the derivative of the ln of y is y prime over y is equals to, now we differentiate 2x and hold this remaining term constant. If you differentiate 2x, you just have 2. So 2, and then you hold the ln of x, the ln of sin x cubed constant, and then you add plus. So you hold 2x constant, and then differentiate ln of x, that's 1 over x. And then you hold the ln of sin x cubed constant. And then you add plus. You hold these two functions constant now, and then you differentiate this one. So we hold 2x, the ln of x constant, and then we differentiate ln of sin x cubed. Now that's 1 over sin x cubed, sin x cubed, multiplied by the derivative of sin x cubed. So the derivative of sin is cosine, so we're cosine x cubed. You multiply this by the derivative of x cubed, which is 3x squared. So we have y prime over y is equals to 2 ln of x, the ln of sin x cubed. And then here we can simplify, so s and s here will cancel out. So we just have 2 ln of sin x cubed. So we have plus 2 ln of sin x cubed. 2x times 3x squared will give us 6x cubed plus 6x cubed. Now the ln of x is here, so we have the ln of x. And then cos x cubed divided by sin x cubed is cotangent x cubed. We can check if we can find out our least common denominator. So we write y prime over y is equals to 2 ln of x, ln of sin x cubed, plus 2 ln of sin x cubed, plus 6x cubed, ln of x, cotangent x cubed. So we are seeing 2, 2, 6. So the least common multiple for these coefficients is 2. So we have 2 onto, here we have ln of x, ln of sin x cubed, plus ln of sin x cubed, plus this is going to give us 3x cubed ln of x, cotangent x cubed. We are going to have y prime over y is equals to 2 bracket open. Now in here I have ln of sin x cubed, ln of sin x cubed. I can factor out the ln of sin x cubed and I will be left with ln of x plus 1 and then plus 3 s cubed ln of x, and then the last one there is cotangent s cubed. I'm going to multiply the entire expression by y. So I'll have y prime is equals to 2y into the ln of sine s cubed times the ln of x plus 1 plus 3s cubed, the ln of x, cotangent of s cubed. But I know what is y. From the beginning I know that y is equals to sine square s cubed all raised to the power of the ln of x to the x. So I'm going to write that here. I'm going to write y prime is equals to 2 sine square s cubed. So it's sine square s cubed all raised to the power of ln of x to the x multiplied by the ln of sine s cubed multiplied by ln of x plus 1 plus 3s cubed ln of x cotangent s cubed. Ladies and gentlemen, this is the derivative of sine square s cubed raised to the power of the ln of x to the x. Was this video helpful to you? If it was, we admonish you or encourage you to check out other videos on this channel or subscribe to the channel for more videos. Thank you very much, and